Good morning everyone. I am Saranya S, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women, Hosur. Now I am going to discuss about matter waves in quantum mechanics. Let me discuss one by one. First, what is meant by matter wave? So matter wave means wavelength associated with any moving particle of momentum. That means any matter which has both the particle and wave nature, means dual nature of particle. So de Broglie proposed about the dual nature of particle, which is lambda is equal to h by p. Lambda is the de Broglie wavelength and h is the Planck's constant, p is the momentum. Momentum p is equal to mass into velocity. Here the difference between normal electromagnetic waves and matter waves. Next, what is meant by wave packet? When number of plane waves of slightly different wavelength and frequencies travel in the same direction. Here a group of waves are formed. These group of waves are called wave. And what is the difference between phase and group velocity? Phase velocity means the velocity of propagation of a wave is the velocity of displacement of a given phase, which is called phase velocity. Group velocity means each group of waves that moves with a velocity is called group velocity. And the relation between phase and group velocity. Two phase velocity and one group velocity combine to form a group of wave packets. Look at the picture. First two waves are refers to phase velocity and third one refers group velocity. So two phase velocity forms the same phase, same amplitude, same modulation. So wave packet means the superimpose of phase velocity and group velocity to forms a wave packet. So what is meant by phase velocity? Vp is equal to omega by k. Here omega is the angular frequency and k is the wave number. So Vp means frequency into wavelength. So now substitute the value of nu and lambda in phase velocity Vp. After substitution, we can get Vp is equal to c square by nu. Next, the relation between Vg and Vp. So Vg is equal to Vp minus lambda into dou Vp by dou lambda, which is equal to Vp plus k into dou Vp by dou k. Here k is the wave number. Next, Davison and Germer experiment. So first let me discuss about the experimental arrangements of DG experiment. So look at the picture. The electrons are accelerated through a potential difference V in the electron gun. This electron beam falls on a large single crystal of nickel. The electrons are scattered in all the directions by the atoms in crystal. The detector can be moved to any angle phi relative to incident beam. The energy of the electrons in the primary beam, the angle at which they reach the target, and the position of the detector would be verified. So G.P. Thomson experiment, let me discuss. The experimental setup for G.P. Thomson experiment. A beam of cathode ray is produced in a discharge tube by means of an induction coil. The electrons passing through a fine hole A are incident on a thin gold foil F. The thickness of the foil is about 10 power minus 8 meter. The emergent beam of electrons is received on a photographic plate P. Visual examination of the pattern is made possible by the fluorescent screen S. A very high vacuum is maintained in the camera part of the apparatus while air is allowed to leak into the discharge tube through a needle valve. This is the experimental procedure for G.P. Thomson experiment. Here the beam of electron is passes through the thin gold foil and the diffracted image is focused on the photographic plate. Finally, we can get the diffraction pattern on the photographic plate. So clearly this experiment demonstrates that the electron beam behaves as a waves, since diffraction patterns can be produced only by waves. Thank you.